Hello Physics Honors, I'm Robert Sweeney. If you're watching this, you might need help on number 6, 7, and 8, but don't worry because it's practically a really fast and easy problem once you know how to do it. So we're not gonna read out the entire question. If you need help, just follow along on your quest and we'll show you how to do it. So what we know is that the train starts accelerating at point A, then goes at a constant speed, and then slows down. And this is a velocity graph right here. So what we know is that it starts off at A, so I'm going to mark my points here, then goes to B right here, and then starts at a constant speed until it reaches to checkpoint C, and then stops at the station, which is called checkpoint D. Now, what we want to find is how much time the train spends in between these intervals right here. So how we're going to do that is we're going to use displacement. What we know, since the train is going straight, the displacement is just equal to however far the train has gone, since it doesn't stop or go backwards.
Start to end.
Start to end. So the displacement for A and B is equal to the area under the line here. And the way we find that is the base times its height,
So
divided by 2.
Area of the triangle.
Area of the triangle, right. And that's actually equal to the interval of C and D right here.
They're both triangles.
They're both triangles, so that's base times height. So that's for the triangles. For the rectangle, we're going to use base times height. Right here. So the problem that a lot of people have on this is that they think that there's not enough information for the equation. But the interesting part that they give us is that the distance between these points are equal, and that's all you really need. Because the height, right, is how fast, since this is a velocity graph, it's how fast the object is moving, and the base is the time. Since we know that the height of this triangle is equal to the height of this rectangle, we know that they reach a maximum speed. So we can just eliminate the height of each one since the heights are equal. So now that we know is that the time that it spends in this area right here is half of what it spends in this area, meaning that it takes twice as long for the train to travel from A to B than it does from B to C. So let's just say that the time between B and C is X. Well, we know that this time takes twice as long, so we'll put 2x. And we know that A and B is equal to C and D, so we'll put 2x here. And we know that all these times added up is equal to 5.36 minutes. So 2x plus x plus 2x, that's 5x, is equal to 5.36. So all we have to do is a little bit of algebra. 1.07. So now we know the time for this, which is 1.07. So now the times for the 2x obviously is twice as that.
2.14.
So 2.14. So okay, so now that we got all of this, we can just do 6, 7, and 8 super quickly.
A to B.
So number 1 asks, how much time does it take from A to B? Well, we already know that it's 2.14 because it's twice as much as this. Number 7 is B to C. We know that, 1.07. And number 8 is the same thing as number 1 practically because they're equal times. So that's also 2.14 minutes. So just to write it down, A, B is equal to 2.14.
These are points.
B, C is equal to. This is for all those not familiar with calculus graph. This is intervals, so don't worry about it. And C to D 2.14. This is 6, 7, and 8. Thank you.